Howdy, y'all. My name is Price, and welcome back to some more Slime Rancher. It is October 25th. How y'all doing? This guy's looking all right. I don't know exactly what we're gonna be doing with this character. We gotta figure that out. But how y'all doing? Y'all having a good day? Y'all having a good time? I hope so. It is Tuesday, which means I just streamed. I love this guy. The Rock over here. The Rock Slime. If you smell... No, maybe if you see what the Rock Slime is seeing. Anyway. So, we streamed today. And I almost streamed this. I was curious, actually, what y'all think. Comment down below. What y'all would think about me doing this file on stream, or is it like, do you really prefer it being me like the one-on-one and not talking to chat and stuff for this series? Because like that's kind of been the precedent. Now that we've been doing this for over a month now, a couple days over a month, I'm starting to try and think about kind of ways of like shaking this up every like couple months, every month or so. So like still having Daily Slime Rancher, but maybe a new file or a new mode or like challenges or just like some kind of redo. I don't know how I would do that yet. Just kind of on my mind. Just kind of something squeezing my mind grapes. Let's get up here. We're gonna look for some more primordial oil while we're out here. Whoa. Was that y'all? That was weird. Okay, so on stream today, we played Coral Island, which is a super neat game. If y'all haven't seen it, it's like a Stardew Valley-like. Very neat game. I really enjoy it. So I want to start... I'll post that for y'all sometime this week. Part of me is thinking almost that maybe... for the Daily Slime Rancher, maybe it's like every weekday. And then on the weekends is when I can post like other stuff, you know? So then like Saturday I could put out Coral Island. Maybe on Sunday I'll put out something else, like a plate up or something like that. Because I do think that having more than an hour's worth of content every day is a little excessive. I feel like a lot of y'all are struggling to keep up with this series, which totally makes sense. So yeah, curious about that. If y'all think that's cool. If y'all think it still counts as Daily Slime Rancher, if it's just every weekday, you know? Or we change the name to it, like, you know, weekdays with slimes. Okay, we're looking for more primordial. So, yeah. Definitely want to keep playing more Coral Island. We'll probably be doing that on stream for at least a little while. Sorry, once again, my voice is going because it's been a long day. But yeah, it's a lot of fun. It's a lot of fun. Very much a Stardew-like game with elements of, well, like the characters are really, really well designed, and they're sort of in this almost like, we kind of likened it to a bit like a Disney style, almost like a Pixar style, or like, I likened it to sort of a more realistic Lilo and Stitch style. Takes place in this very Asian-inspired town on a little island. It's got these elements of ecology where you need to like clean up the environment and stuff. It's only in early access, so there's a lot of stuff that's not in it yet, but like I know that they're gonna have like mermaids and stuff like that. It's gonna be awesome. So, definitely looking forward to playing that game, and I think that y'all will enjoy it. So keep your eyes out for that. And, you know, let me know down below if there's any other games you would like me to check out. I think the main thing going forward is we're going to be doing Daily Slimes, where I just kind of check in with y'all. It's the Little Price podcast. And then small series. You know, I'll play a new game for a little bit. Then I'll play a different game. You know, maybe we do a couple episodes here and there of each one. But keeping those small. I don't want those to get too big. Even if I keep playing them, you know, I'll want to mix it up for what I put out here because I know that just like after a point, a lot of y'all are like, all right, I've seen enough of this game. And so I just want to make sure that I keep doing lots of, keep the variety up. Because that's, I know that's what a lot of y'all like. Okay. What we got going on here? Like, I really just want to find some primordial oil. Could you please give me the primordial oil? Doop-a-doop-doop-doop-a-doop-doop. Okay. You know, not a bad amount. Over 10 is good just in terms of, like, what we tend to need for each item. But, you know, I'd like to get more than that. I'd like to get more than that. Let's grab you. Come on. Come on. All right. Now, what else we got around here? Okay. So, yeah, I mean, that's what I've been doing for playing other than playing Astroneer, like I've talked about. I do want to play that for y'all soon. We were going to maybe do some at the end of stream today, but we ended up just keeping on playing Coral Island. So maybe next week, like maybe I'll alternate doing other stuff. You know, we'll see. Like I said, I'll start turning the weekends into maybe other content. And that'll also help me to like catch up on Slime Rancher Daily, because it's the weekends that get hard because of Stumpt recordings. So I think that that could work. So yeah, maybe this week I'll do. Y'all get to see the Coral Island, and then you know the new Played Up Halloween update is out. So I want to make sure to play that while it's still spooky season. So I'm planning on recording some of that either today or tomorrow. Probably going to be tomorrow, considering my voice is already kind of like, Bryce, it's been too much today. So yeah. Just going to go ahead and get some more of this stuff. All right. Doop-a-doop. Grab you. Okay, so I'm trying to think, other than getting resources, what is it that we need to do today? So, like, let's think. Whee! So we're still working on Gordos. So I got to figure out Gordo zones. Decorations, which is why we're getting the resources. What else? I don't know, to be honest. Okay. Let's go over here. You know what, y'all? My voice is really, like, going right now. I think what I'm going to do is I'm going to go make some tea. I'm going to go relax my voice for a little bit. So I'll come back in an hour or two. And if my voice is still not feeling it, I will record the rest of this in the morning. Because, yeah, as you can probably hear it. It's a little bleh. So, I will, see y'all, when I see ya. Give me this. Give me this. Okay. See y'all, a little bit later. All right, y'all. I have returned. It's been like maybe an hour. I got some tea, kind of sat down and rested a little bit, took my other pill, because it's about that time. And, here we are. I think my voice feels a lot better. It may still go in and out. We'll see, but, feels a lot better, so I shouldn't be causing myself any hurt, any discomfort. Okay. Let's go. So, I guess getting on to a topic for today. I know, we had talked about vision, not too long ago, about like the pathway of vision, how it works. We kind of just stopped. We're mostly talking about light. We're mostly talking about like light physics and how like color works and stuff. Give me a sec. Okay, we see anything? So, I'm trying to think like what to add on top of that. I guess one of the things that's super interesting is that the way that we construct our knowledge of images. So you might think that your eye works kind of like a camera, where it takes a picture of objects that's just one-to-one, it's a perfect picture, and it's just taking pictures. It's like a one thing. So it's like it's, you know, watching a TV or something. But that's not the case at all. Our brain actually picks things out and highlights them and whatnot, like figures out what's a shape, what's alive, what's not alive, what is in the distance, what is close to us. And it does this in really interesting ways. So we talked in a previous episode about how your consciousness is... Oh, hey! Any chickens around here? Hello? Hello! Whee! There you go. Hello, the luckiest of cats. I got you. I took your picture. I might draw a picture of him. Ooh, maybe I'll draw a picture of the beetle for the next one. Yeah, I'm wanting to... Is there another one? Was that... Oh, didn't mean to go through that portal. No! That was a whoops. Okay, well, that was one way. I was trying to get a picture of the beetle, but I can get it from somewhere else. Sorry, not beetle, like firefly is what I've been saying they are. We'll go turn these in, then we'll go look for some jellystone. Maybe do a sleep and do the same again. Because, you know, it'll help us work on decorations as well. I'd like to kind of maybe pick a zone and then make a bunch of stuff for that zone and kind of clear it out. Like, so for our... Oh, oh yeah, I don't need this food, right? We popped all the pinks. We're waiting on to see if the baddie works out. Those guys are hungry. Beep, boop, bop. Just like zooming through. I'm like not even trying. Here you go. Okay, that's y'all. Let's get y'all's faves. All right. Beep, boop, bop, boop, bada, boop, 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 bada, boop, boop. Okay. So, before, in the previous episode, we talked about vision. I mentioned that it's our vision, or our consciousness, sorry, when we were talking about consciousness, that it's a gestalt, is what I called it. And so what that means is that it's sort of like greater than the sum of its parts, all right? So it's like something more than just what each of the pieces represents, right? So... the way that this works is your brain actually has multiple, you can think of it as multiple passes, like multiple different things that come together to form an image. And this is stuff that like is big on like AI, like AI image recognition and face recognition and, you know, finding things within an image beyond just looking at the image, right? Because that's, if it weren't for this gestalt, the way that this works, and I'll talk about it in a second, then, you know, it would work exactly like a picture and how like an AI would show you a picture, right? But that can't identify the objects in the picture and what's going on in the picture and like, you know, separate it. And so it's being able to separate it. That is like our, how our brain functions. It's what works. It's how it do. The way that this works is, like I say, through these multiple passes, essentially. And they each correspond to, like, different traits within an image or within what you're looking at. So one of which is lines, all right? We look for edges of things, okay? See this right here? Clear edge. That's a clear edge. We can see that. And you know how else we know that for sure that's an edge? When we move, the things around it move in a certain way, and this edge kind of obscures things behind it. So it's like, oh, okay, this is in front, and it's an edge, right? Our brain looks for edges, okay? Because that's how we know where specific objects, right, are in our world. It's not about a whole image of our world. It's about a bunch of objects within a space, right? And so that helps us to be able to interact with objects more and identify them. So the way this works is you actually have all of these cells inside your brain in the these neurons in the occipital lobe that, well, let's take a step back. So getting to lines, you got to start somewhere, right? So let's think of pixels, okay? Think about pixels. So we talked about how light enters your eye and how it interacts, you know, with your eye. And basically what happens is light turns into neuron impulses, like neurological impulses, neurochemical or electrochemical impulses. So that message from your eyes gets sent down into your brain. deeper into your brain, because all cortical tissue is brain. And passes through the thalamus. So what happens at the thalamus? So first things first, the information that comes from your brain or from your eyes is unfiltered, all right? It's perfect information when it first gets processed. But then at each level as it goes forward, it gets like compressed, essentially. And then when it reaches the thalamus essentially is like, I've called it like the secretary of the brain in the past is what we called it. So like, it's like the office manager of the brain. It basically organizes all of the information and it sort of prioritizes. So it basically says, okay, this visual information is important. This stuff, not so much. So already you're kind of missing out on some information, right? Your brain's already making decisions for you saying, you know what? You don't need to know this. Okay, so you're not getting all the information from your eye right away, all right, or ever. So that's one thing to consider. Even right at the base, your thalamus is telling you, you know what, you don't need this information. Okay, so what gets sent forward through the thalamus gets further and further processed as it heads deeper into the occipital lobe. Essentially, at the farthest back end of your head, like hold your hand on the back of your head. So that and right where like there's that like kind of like bump on the back of your head, you know, or like where your spine kind of comes together. So hold your hand on the back of your head, and that right there is your occipital lobe. All right, right behind your skull there, right past your skull is your occipital lobe. The farthest back end is where the most basic processing occurs. So that's like the earliest levels of processing. So you'd call that basically the lowest level of processing in the occipital lobe. So from the pixel information, we get line information. So what does that look like? Well, we have all these essentially pixels kind of spread throughout our brain going there as they're processing. And then what we look for is, like I said, those edges. So we actually see when we look at brain responses to stimuli, like lines where you like basically you take like a piece of paper or something and you drag it along in front of something, right? So that you see the edge moving, and you can see that there's specific cells that focus on vertical lines. There's specific cells that focus on horizontal lines, and then all the lines in between. We have a lot more cells dedicated to horizontal and vertical lines than we do the rest of the types. Essentially, 90-degree angles are so easy for us to understand, right? And then 45s also, because it kind of mathematically fits really well with those. But then all the other ones in between, sometimes it's hard, right? To be like, is that a 20 degree? Is it a 22 degree, right? That's tough. And, you know, part of that is because we have more cells dedicated to those cardinal important directions. Real quick, let's see what our message is about. Thora, what you got going for us? Hey, B, I know it's silly, but I worry about the hard work you do out there all on your own, so I sent you a little care package. Hope it gives you a little extra. Get up and go. Another short palm. Okay. We can fill out our little beach here a little bit more. So you got those line cells. And so here's a very sad thing. You know, research has always been done in ways that were unethical in the past. They still are often unethical, but are far less. They're far more ethical nowadays in the field. Is that there were a lot of studies done on monkeys and on cats back when they were trying to understand cortical tissue. And it's very, very sad. It's very sad. When you read about it, it sucks. So what they did to figure out some stuff about these cells was they actually raised animals in settings where they did not see horizontal lines, I think. It was one or the other, vertical lines or horizontal lines. They basically created an environment where they never see those lines, which, as you can already imagine, is like an incredibly difficult thing to do, but also, wow, how awful is that to do to someone or something, you know, any creature. But what they learned as they were trying to figure it out is like they were trying to find like specific places where certain like dots would appear, or certain like areas on the cortex, like trying to figure out like what they do and everything. And they were having trouble finding it. Like they had these like, you know, electrodes hooked up to these animals' brains. And what they found was like they were trying to show them slides on a, what do you call it? They were trying to show them slides in order to like see how they were stimulated by whatever was on the slide, like old like glass slides. And as they pulled it across like while they were changing slides, as they pulled it across the projector, then they saw a lot of activity. And it was as the line was getting dragged across. Like as the line moved, lots of activity. And so that showed two things. A, that the lines were very important, but B, motion is very important. So that's the next part, right? So we have going further and further up into our brain, right? We've got this one layer of shapes. It's trying to find objects and shapes. So that's the lines. The lines get more and more complex as they go up. So it's like we suddenly have like curves and shapes and other combinations of lines. And it seems like we even go so far into the brain that there may even be cells that are dedicated to like people in your family, like people who look like you and that you've seen so many times, because of how it develops, right? Your brain kind of matches the environment that it is growing up in. And so yeah, it seems like there was this whole bit of research that was about finding the grandmother cell. And it was like, where's the cell in your brain that that knows what your grandmother looks like, essentially. And so that is one of those things that, like, obviously you get a little bit more into a gray area. But what we do know is that we have areas in our brains that are dedicated to human faces. So we have incredibly complex responses to human faces. And then as you get further and further away from the human form, we have less and less cells dedicated to like understanding that form. So if you think about it, this is why we don't really notice the differences in faces of animals, right? We don't have enough cells dedicated to what the face of a lizard or something like that looks like. But if we had a number more cells, you can imagine our brains would create detail in there that we aren't currently aware of. Because remember, our brain is taking information away as it comes in. And we don't need what is a fish's face and the differences between a certain species of fish. You know, what is Harold the fish and Maud the fish? What's the difference there between them? We don't really need that information. Why am I throwing those in there? They can't eat those. Whatever. They'll decay. That's right. None of these can eat these. That's why I'm confused. I need to get rid of these things. Okay, so anyway, we don't need that stuff. So our brain's like, we don't need to process that information. We get rid of it. But the information's there. Okay? So just consider that for a moment. But things like apes, which we are closely related to. All right, what am I doing? I'm just running back and forth. Okay, I reset the day. All of our critters seem fine. We're going to go get more resources. Okay. So yeah, we have these cells that are dedicated to like human faces. As we look at like apes, like chimpanzees and orangutans and stuff like that, we can see a lot more detail in those faces. So if you go and look at some pictures of like chimpanzees or bonobos or any of those animals that are very closely related to us, you can kind of see it, can't you? You can kind of see differences in their faces. Not fully, right? But you can tell the difference between a lot of them, a little bit more than maybe between two tigers or something, or two lizards, you know? The closer and closer you get to us in species, the easier it is to determine differences between individuals. So, There's apes that are closest to us. That's the one we can see the most. Then it's, you know, up to like mammals, like as the larger kingdom. Is it kingdom? Mammals? I don't know which one it is. I don't think it's kingdom. Phyla? I don't know. Anyway, so mammals, right, are kind of, you know, we are mammals. It's a larger net, but, you know, we can tell those ones a little more. You know, you can kind of tell the difference between your dog's face and another dog's face, right? There's differences there. But then as you get into like reptiles and fish and things like that, it becomes a lot harder. But there's still differences there. Like for those species, there are still differences in how they look. It's just, we don't need that information. Okay, anyway, tangent there. We have cells in our brains dedicated to human faces. They are incredibly complex and focused on the shapes of human faces. And we don't have them dedicated to other things, and that's why we don't experience them in as varied or great of detail. So just know that, like, it's hard to reframe this, right? Because it's really hard to understand that what you are looking at is essentially an image that is compressed in certain areas and high def in other areas, but you don't get to tell the difference. Does that make sense? So, really trippy stuff, right? Okay, so we got cells dedicated to the very complex and unique shapes of faces and things that we experience as humans on a regular basis. This also, on the flip side, may be a huge part of an explanation behind why we do with the uncanny valley. Because our brains are so geared to looking for faces, when we see something that is both a face but not quite a face, it's pretty terrifying because we can't classify it as whether or not it's one of us or not. So that could be one explanation, right? I'll say there's what I would call the far-fetched explanation that kind of like it assumes that fear works in only one way and that our evolutionary fear can only be based on predators, which is not the case. And so there's this whole thing, you might have heard this before. Has there been, we got a little bit of Jellystone. We'll keep looking. There's this whole thing, people who talk about the uncanny valley and they're like, but if we're so afraid of these things that look kind of like people but aren't people, then what was it that we, experienced in the past that made us so afraid of it? There's nothing evolutionarily that says that fear has to be based on predators or danger in that way, like imminent danger. You can see this in that many people are afraid of, say, things like the ocean or being compressed, like claustrophobia and things like that. And a lot of these have to do with mortality, right? Your safety, but not having to do with like predators or imminent danger. And so part of what the fear of us seeing a face but not quite a face could be is the potential threat of danger, but also the unknown. The unknown is scary. You know why you're scared of the dark? Because you can't see. And so whatever's out there, you don't know what's out there. But it's not like the dark is chasing you like a tiger, right? But you can still be afraid of it. So I would just say, consider that before jumping on the bandwagon of we must have fought weird vampire things in the past or predatory humans that are no longer around or whatever. The only other humanoid species that we would have interacted with that could have potentially caused that fear would be other humans, and maybe like Neanderthals or other similar humans of humanoids like us. Like they were humans. I mean, let's be honest. We could breed and whatnot. So these are all forms of humans. We are Homo sapiens sapiens, but there's Homo sapiens neanderthalis or neanderthalensis. Whole bunch. So it's one of those things of there was more special, I don't know if that's not a word, diversity in humans, and then it had kind of bottlenecked because essentially we fought ourselves to extinction in all those other ones. But you could also say that to a degree it was also like interbreeding between those different species. Man, what a tangent I went on there. But so for example, when it comes to like what I just said, there's actually evidence that many people in modern day, maybe all, I'm not sure. I don't think it's all though, but many, many, many people have some level of Neanderthal DNA. It's, something to the effect of like maybe 12 or 15% or something like that. But DNA that we know came from Neanderthals, like through like direct breeding with other humans, with Homo sapiens. Anyway, neat stuff, I think, really cool stuff to look into. There was a book that I read called The Neanderthals Enigma, I believe. I would say check it out if you're interested in that kind of stuff. There's also a book called The Third Chimpanzee, which is another book that deals with kind of the evolution of apes in particular. Anyway, love those two books. Let's move on. So, cells for faces. The uncanny valley is probably just because we can't process it properly, and anything that we don't understand or know can be terrifying to us. Okay, so beyond that, we have cells dedicated to motion. And so that's what I was going to say about that thing about the slide moving across and that having an effect on our vision. Essentially, we have cells that are dedicated to motion in different directions and to those different lines and shapes moving in those directions. And so not only do we have a layer of the lines and shapes, but we have a layer of the, how are we doing? Okay, we need a little bit more of each of these, yeah. But there's a layer of like motion processing. And we know this because we see that these different components of vision are processed in different areas, right? We can show that, oh, the motion is processed over here because these cells only are active when they're exposed to motion. Oh, these cells over here, they are the lines and shape cells because they only show activation or responses when exposed to lines or shapes or whatever. So it's like, okay, we know we know those two things are separate. So what's really interesting about this motion stuff is some of it happens like within your eye, and a lot of it has to do with differences in contrast and how those move, which, by the way, we have another layer of like contrast and shadow kind of processing, basically like the like shading of things, and then another one of coloring, and then there's all different kinds of ways that we actually perceive depth, which is a whole other kettle of fish. But we'll start with, so, we have those motion cells, and then, we have sort of like within a shape, what is the shape of a shape, right? What is the three-dimensional component of that shape? Get out of here, Tar. I'm trying to talk about important student learning. Now you come in here, now I have to give them an extra test to make sure that they caught up. Now, Terminator. My students do not want another pop quiz. Okay, sorry. Anyway, let's look around for some more stuffs. So yeah, like I said, processing sort of the shading of a thing, right? So we can look within this anglerfish shape, and obviously we see the kind of depth that it has because it has all of these things that we're used to, like shadows. Shadows are things that make a certain amount of sense to us, but they also have some confusing elements to them as well. And this is like the stuff that I love about perception is the stuff about how our brain gets confused, because it really proves to you that you can't trust yourself, which I love. I love knowing that because it gives you the knowledge that like, oh, everybody messes up. We should be really thoughtful towards other people when they make mistakes. Always assume it was a mistake and not on purpose. Give people the benefit of the doubt, because we all have perceptual systems that fail us. I'll say this right now. If you're ever in a conversation with someone and they say something and you immediately jump to, that's not what I said, or this is what I did, or et cetera, et cetera, et cetera, et cetera. Like if you just go straight to like a fight because of a thing like that, I would say that that's not optimal. I would say always double check with someone, be like, excuse me? Like, what were you trying to say? Right? Are you sure? Right? Like, double check. Try and confirm, because there's a good chance, not all the time, right? But every now and then, there's a chance that it was just a misunderstanding. That it was legitimately, you said one thing, but my perception was another, or I showed you one thing, but you thought you saw another. These things can be true. You can have seen something that I did not show you, right? Because the thing that I showed you could have looked differently to you. Maybe you saw it really quickly, and your brain has cells that kind of like recognize that shape as a different thing because it's something that you were exposed to as a child. And so really quickly, you didn't see the thing that you're actually seeing. You ever out of the corner of your eye think you see someone wearing like a yellow shirt, and then you turn and it's actually like a blue shirt or something like that, and you're like, huh, weird. because your brain's filling in some blanks until you get more information. It's like, oh, it's a light shirt. Ah, dang, pinky. Anyway, I'm on a tangent, but essentially, your brain lies to you all the time. So be thoughtful towards other people when it comes to things like that, because it's entirely possible that they just perceived something slightly differently. No one, period, zero, no one has a perfect understanding of the world through their perceptions. It'll never happen, even with AI, because they're programmed by us. So they're gonna, be biased towards us. Like the facial recognition settings of an AI right now, they're not really set to the face of a dog. Anyway, so that all said, we have all these different visual processing centers. They give us all this different information, and then our brain does the word that I talked about before, word of the day, gestalt, which puts it all together into one image that we view from all of these different components. But remember, so this is an image that is not perfect. This is an image that is stretched, compressed, that is, what do you call it? I'm trying to say the contrast is increased in certain areas and reduced in others, right? It's exaggerated in certain areas and diminished in others. That's what I want to say. Sorry, just looking for primordial oil. So it's important to recognize that because, the world that you're looking at is not fully representative of the world. Now, that said, that's not like you should think like, oh my gosh, I have no idea what the world is. It's more, you should understand that the information you're getting from the world is incomplete. So you need to know that and know kind of maybe your weak points, right? Which all humans have a lot of weak points that are common. So that you can better understand the world, right? If you know where you struggle, then it's better to work around that struggle, right? This is the same with any mental health issues. It's the same with anything about yourself. If you first know about it, if you have an understanding of it, it's way better to be able to handle it. Even if you're not changing anything about it, knowledge helps you cope, right? And so our brain in many ways copes with these things, but also knowing it, you can maybe lift some of your maybe you have, like, I would put it this way, like, you don't have to feel so bad about maybe mishearing or misseeing things or misunderstanding things, right? It's not necessarily your fault. Not only could you have a focus disorder like me, like something like ADHD, which causes you a lot of difficulty in comprehending and understanding things because of attention issues, but also your brain drops out information all the time. And, if you were focused on one thing and then someone says something while you're in the middle of that, your brain may have been like, look, this information over here is not important. We're focused on this thing. That's not necessarily your fault, right? Like, there's a certain degree of your brain acting against you. And again, I also want to be like, I'm not giving you an excuse. Don't let me say this is me giving you an excuse. Like, oh, Price said I don't see things fully, so that's why my get out of jail free card. Not saying that, right? You're still responsible for your behavior, but knowing it, not only can you understand when maybe you struggle with things like that, but I think it also means you can be better at apologizing about things when you make mistakes because you understand that you totally can make mistakes and you understand that other people can make mistakes. And so you can be more generous towards others is the way I like to think about it. I like to give people the benefit of the doubt because I know it's entirely possible that I misheard them or they misunderstood or there's something that's like a barrier between us, whether psychological or perceptual. Okay. So it's so weird how like I go from telling you about like how your brain works into let's talk about some philosophical stuff. But that's kind of the beauty of perception, right? It's the machine of how I understand the world. It's the machinery, right? And then my brain and all the other areas, like in the frontal lobe and whatnot, that's where I get to see the world and then be like, I wonder, and interact with it, That's the beauty of what we're able to do as people, right? Is, I've heard people say this before. I like this phrase, I think it's a poetic one, and I think, there's a degree of truth to it. I mean, for some people, maybe it is 100% true. I don't know. But it's this phrase, it's, we are the universe looking back at itself, which essentially, like, because we are complex, intelligent, sentient beings, right? There is a thought that, oh, okay, we are the universe, right? We are a part of the universe is a part of us, et cetera, et cetera. Take a picture. Essentially, because we are a part of the universe, and we're conscious, we are essentially the universe going, huh, and interacting with itself. That's kind of, I think it's a neat poetic way of saying it, you know? It's sort of adds some like spirituality and whatnot like that, I guess. To me, it's just more of like, I think, yeah, I think there's a level of truth to that, just like factually. We are a part of the universe and we are looking at it. So I find that super interesting. I find that kind of stuff super interesting. And I don't know who that quote's from. Maybe it's Carl Sagan, but I don't know. Actually, you know what? Let's look it up. Let's look it up real quick. Let's be a good boy here. Universe looking back at itself. Alan Wilson Watts. Through our eyes, the universe is perceiving itself. Through our ears, the universe is listening to its harmonies. We are the witnesses through which the universe becomes conscious of its glory, of its magnificence. What a beautiful, beautiful thing. Okay. Beautiful. Okay. So, all right. Beyond that, what are we talking about? Okay. So, the further constructivist nature of how we understand things. So, how do we see 3D? All right? So, you've probably heard before, right? This is like a super huge one. We have binocular depth cues, right? We have two eyes, they face forward. That's what gives us depth perception, right? You probably know that. Well, that's not entirely the case. It is one component of how we perceive depth, and it certainly is a very important and powerful one. But even if you only have one point of vision, one eye, or some combination of visual issues, visual disabilities, you can still see depth, right? It's not like suddenly the world is flat. And it's because there's a number of features within the environment that our brain uses to determine those things. One is a very simple one right here, is occlusion, all right? If something blocks another thing, that thing's in front, right? So those pink guys back there, they're being occluded by this rock, right? You see that? So they must be behind it, right? Because things in behind don't go in front, right? So they must be behind. So that's one of the things our brain does. There's processing centers for that piece of information. There's also a thing called haze, which is, if you look into the distance, there's a perfect example here. It's wonderful. Okay, as you look into the distance, it becomes foggier, right? Things become a little bit harder to see. They're a little bit more muddled. But also, and here we don't fully see it, but they actually change color. Like in real life, as things fall into the distance, they fall into a more blue or grayer zone, often, as that's just the way our brain is processing it through the haze of the air. I don't know if you remember from the last time we talked about perception, but you know, the sky, it's blue because of light interacting with water vapor, essentially, in the sky. Get out of here, Taz, I'm trying to give a lecture. We try to talk about the gestalt of monocular depth cues. All right. Anyway, yeah, we call those things monocular depth cues, by the way. Binocular depth, that's us seeing with two eyes, but we have monocular depth cues, which is us using information about the world as we know it in order to perceive where things are. And how far they are. So haze, that's one. That's basically what you can see here. As things go off into the distance, they get a little bit blurrier. Now, you can still see the edges and everything, right? But like the surfaces of them, the contrast and everything, it dims a little bit, it muddies a little bit. And it's because there's some of that water vapor in the way because it's still atmosphere, right? And so there's an interaction with the light bouncing off of that towards you. There's a small muddying of it the further back you get. But that only works with like things that are really far away, right? That doesn't work with things that you're up close to. But haze is definitely one that does that. And I know I'm going to forget some of these depth cues. There's so many, and I used to teach on this, and it's going to make me so sad that I don't know all the monocular depth cues off the top of my head. Oh, another one is texture. We know that as things move off into the distance, they get closer together. So like right here is a good example with these grass blades. You can see right here, these grass blades are kind of farther apart. You can see how big they are. It's got this texture to it, right? Look at those ones back there. They're clumped up more. They're smaller and they're tighter together. They must be in the distance, right? Because we assume, right? Our brain makes a lot of assumptions. We assume that this grass continues in the same fashion. But those things could be right next to each other, and it could just be small leaves right up next, or small grass blades right behind tall grass blades, and we don't have another monocular depth cue that tells us that it's not right there, right? So there's all these like optical illusions that come about from the way that we see things. So along that same line, there's relative size. We have knowledge of certain objects, and we know certain objects should be bigger or smaller based on their position within a space. So we have like perspective, right? So I know that going off in front of me, lines converge towards the horizon, right? Like that's just a natural thing that we know as people who move on a horizontal plane. Well, in a three-dimensional space, but we basically move on a horizontal plane. So we know about that. Just our brain just knows that there is perceptual distance. And so if we can see perceptual lines, like if we see, say, like train tracks going off into the distance and they converge, and we see things next to those train tracks, then we are going to make some judgments about how far away they are, right? We're also comparing things in reference to the horizon line. The further something is, standing, right? The further the base of something is from the horizon line, the closer it is to you, right? So let's get an example over here. So we're looking off into the horizon. All right, yeah, we got a couple of different things here. So the horizon line, right? It's the easiest way to understand a horizon is it's that. It's where the sky and the ground meet and where it ends, right? That's where it all ends. You can't see beyond that unless you have like, binoculars or super powerful cameras or whatever. So you see that this rock here, it takes up a huge amount of the frame, right? And the base of it is like down here, right? We know that this object originates somewhere down here, which is pretty far from that horizon line. This guy over here, or like these little guys, or like this thing, they all converge kind of close to the horizon line, right? Even though it goes up this high, its base is close to the horizon line. This one, its base is closer to the horizon line. So we assume that those things are further away. Might not be the case, right? There could be things that are like raised up on stuff or lowered on things or whatever that could give us some confusion there. But with the combination of that perceptual depth, the horizon line, and the haze, we can tell the distance, right? So super interesting stuff. What other monocular depth cues can I think of off the top of my head? Oh, shadows. Shadows help a lot with distance and how close things are together and where they are in relation to one another. And what's really interesting is we make assumptions about shadows. We assume that the light is coming from above. And so we assume that shadows orient towards an upper light. And so lights that aren't up above are a little more confusing for us sometimes. They give us weird images and visuals. You know what? I need to go to the other side. I need to go get some buzzwax. Sorry, y'all, I'm getting distracted. I'm talking about stuff. Hopefully y'all are cool with it. I know I've been doing a lot more stopping and talking here, but I'm getting excited. I got to move my hands around. That's how I teach. So yeah, shadows. And what's really interesting about it is that if shadows appear in different ways, in weird ways, sometimes that can confuse our brains. Maybe we think up is down and down is up, and we can get really confused. Luckily, that doesn't really happen too much in the real world, but it can happen with like still images and stuff, or with movies and things, where you can really play with someone's ideas of position and whatnot by altering an image. And that's like a big thing, is that I just completely spaced on what I was saying, like right in the moment. Oof, we'll get there eventually. I think it's because another thing popped into my head about our vision. But yep, that's how it goes. Ooh, is it raining? Or is it just windy? I hope it's raining. So, where was I going? Perception. So we have all these depth cues, we put them together, and they give us... Oh, actually, you know what? There's a bunch of buzzwax this way, isn't there? Usually. That's how we come up with the image of the world around us, is through images like that, or through tools like that. And, you know, that combination of things gives us our visual understanding of, like, things within space. There are other things that our vision does and that art kind of takes advantage of in order to draw our attention, right? There's certain things that kind of make us like, when we're looking at something. You can see this in a lot of paintings, especially from like the Impressionist period where like painters were starting to understand how vision worked. I think I talked about this before with Monet. If you go look at Monet paintings, they're done in an Impressionist style. And in that style, it's more like spots of color. Stippling is what we called it back in the day. I don't know if that's still what you would call it, but it's a stippled pattern where it's basically like dots. It's not quite dots. It's more like strokes, but they're all put together, close together in order to create like optical illusions of color, right? So if you go look at a Monet or like a Degas or, I'm trying to think, who did the Grand Jatte? Anyway, you go look at some of these pointillist, that's right, pointillist paper or paintings, and you know they look like the colors that you're seeing, right? Oh, that looks green, that looks yellow, that looks whatever. But if you get real close to those paintings, you get right up against them, it's actually a whole bunch of little dots, right? And all those dots combined make the different colors that you see. So it could all just be blue, red, and yellow combined together to make all the colors that you see. And because of that, because it's pure tones that go next to each other, it actually makes brighter colors than if you mix things together. Because whenever you're adding pigments together, it always takes away luminance, essentially, brightness. So that sort of is something that has been taken advantage of by artists in order to kind of like take advantage of our perceptual system, right? The more you work with the way our brains work, the better you're going to be able to essentially communicate with people. And in the context of art, communication is like getting across your message and controlling attention, right? You want people to see your image, but you want it to see it in the way that you intended, and then for them to interact with it however they do, right? A lot of painters are like, oh, I just want you to experience this how you experience it, but they still had intention in making it, right? Another thing that this can often be, this can be viewed in is like paintings where it's like a pointillist or impressionist painting where there's different levels of contrast. And so you'll have maybe lots of really tight lines in color and whatnot in one area of the painting, and then very blurry, kind of less defined stuff in another part of the painting. And your eye will naturally be drawn to the more higher detailed area of the painting. It's like your brain wants to put the peripheral on the peripheral and the focus in the focal area, right? Neat, huh? Neat how our brain is like, here's how the world works and how images work, and I'm going to do what's best for you, rather than just letting us see the world. Now, all of this is to say, like, there's a reason that our visual system doesn't work perfectly. The brain requires a lot of energy to work, and there's a lot of unnecessary information in the world that we don't need to survive, right? Because evolutionarily speaking, right, the way that we get our genes to go on, and thus the ways that our eyes work, is through both, survival of natural selection, right? Having, traits that are suited to the environment, and sexual, like breeding, right? Those two things drive that, right? So the social aspect is determined by social means, although oftentimes genetic plays a component in it. But then there's that component of the genetic and the vision and whatnot. And so that goes into it too. And so the reason that our systems don't perfectly process things is because that's not necessary for our survival. What was necessary is information that shows us there's food, that's danger, either run or pursue, right? It's kind of what we need. And then, identify socially relevant or important things around you, right? Ooh, that's not what goes in there. So, yeah. Anyway, so our system, it's built around survival, not like perfection. And so that explains why it has all of these imperfections in it, because it developed slowly over time. It was, you know, certain mutations and certain epigenetic experiences that caused our genes to develop in the way that they did. That's why it's imperfect, right? So there's certain things like, in your eye, you have a blind spot, so an area that doesn't process light. You don't experience the world as having a hole in it, but your brain does fill in that gap. And there are ways to see where your blind spot is. It's super interesting. You should go look it up online, because there's definitely tutorials that show you how to find it. Super easy. It's like draw a circle on a piece of paper and move it. Move it further away from your face, essentially. Hola, Bia. I bought you something that might be nice to have out there. But if you already have one, I can't return it. So the more the merrier, right? Oh, portable scare slime. Whoa, that's cool. That's neat. You could really use that for some stuff. Faster delivery. Chicken hat. Pink guy inside. Happy grilled chickens. All right. Thank you. Oh, sorry, Victor. Okay, new stuff. Okay, I was talking about vision and evolution and how you need to survive. And yeah, was that where I ended? Oh, y'all, the ADHD is hitting me hard right now. But yeah, ultimately, through those epigenetic factors and the genetic factors, we evolve towards more useful genetics, the things that are effective in the world around us. Are y'all hungries? All right, we're going to grab some of these and then we'll go to bed again. I want to see if I can get some more resources, you know? Actually, you know what? We got 10 more minutes. Let me see what we can't build here. I was talking about the blind spot, and there's a whole bunch of other things. Okay, we need one more of those and a bunch more of these to make a couple of things. Let's look at some decorations. Maybe set up a spot. I'll talk about blind spots and whatnot here in a second. The lava area is super easy to decorate for, because it's like, all right, we got lava-y things. These guys could be neat to put in the little, like, I don't know what you call it. The area where we have our hunter guy. I'm going to grab a couple of these. I know that they're costing bus wax, but why not? Okay. Why not? I'm using it all for this today. This is what we're doing. There's more lava-y stuff, right? Oh, so there's... Do I have one of these, or do I have one of these? I think I have one of these. So let's make one of these small ones. Okay. I'm just making a bunch of stuff, y'all. Just making a bunch of stuff. We'll make one of those guys. We'll buy one of those fossils. Sure. Okay. We've used a lot of stuff. We made a lot of things. Cool. And we'll maybe go out and get some more later. So, you got a blind spot, but you don't experience the world with a hole in it. Why? Because your brain fills in the gap. Because you don't need to know that there's a hole there. You just need to know if there's important stuff there. So what your brain does, it's bonkers. This is bonkers, right? It basically looks at what's on either side of it in whatever direction, and just it like fills the gap. It just fills it in. It says, oh, what's here? Clone stamp. That is that's how your blind spot works. It's just in your eye, and the reason it's there is because our eyes kind of develop backwards with the optic nerve, so that, like, essentially the way that your eyes work is that the side that views the light, that experiences the light, is actually on the back side of the retina, and the front side of the retina is actually all of, like, the ends of the neurons, the axons, essentially going down through the optic nerve. Your retina can experience that light just fine, except for at the area of the optic nerve going back into the brain. So that's where the hole is it's where your optic nerve goes back inside your brain. Other species like octopus and whatnot don't have that. So their optic nerve is behind their eye, so their eyes wouldn't have a blind spot. Okay, let's go decorate. Actually, let's do morning first, because it'll be brighter and prettier. And then we'll feed these guys, and then we'll go decorate. Okay, so blind spot. Interesting, huh? Oh, let's check our messages. I'll say this one in just a second. Okay, Mochi's got something for me. What you got? Hey, B, I found something you're going to throw out. Yeah, okay. Awesome! The market link. Let's go. So the market link, y'all, is like the refinery link, but for money. So we basically want one of those on each of those sides so that I can go and throw those plorts into the market link if we want to. So now we're at the point where I will go checking these places more often because I don't have to bring everything back. All right, y'all hungry? Y'all probably hungry. Okay. So another error of the eye. Well, not an error, but a thing that doesn't match. In your peripheral vision, where it's blurry, like you know where it is right now, right? You're looking forward, and it's the vision on the side. It's blurry. You know, move your hands up and down. Once you can no longer see your hands, you're at the far edge of your periphery, right? Just moving forward. Once you can barely see them, that's your peripheral vision. You have no color vision there. There are no cones, which are the color sensing organs, in your peripheral vision. They only exist in the center of your vision. But you don't experience the world as black and white, do you? On the edges with just a hint of color in the middle. No. Why? Because your brain fills in the gaps. So that's why earlier I said, have you ever seen like someone and out of the corner of your eye, you think they're wearing like a yellow shirt or something like that, and then you turn and it's not that? That's why. Because you're filling in the gaps with what your brain assumes is there, but that doesn't necessarily mean it's actually there. Okay? Interesting stuff, right? But then once your brain gets the appropriate information, once you know, oh, it's a blue shirt, you won't forget. Your brain's going to see that as a blue shirt for the rest of the time you're hanging out with that person. As a matter of fact, next time you see them, if you don't see their shirt right away, you might assume they're wearing that same shirt, right? Because your brain's like, here's this important information that I was wrong about. So your brain stores that information and adjusts accordingly. Super neat, huh? The other thing is just about like the nature of how our eyes are structured, because if you look at other species, they all have very different like either orientations of their eyes or structures within their eyes that determine how they can view things. And so, for example, one of the ones, let's actually look around here for spots real quick. Oh, wow, there's a lot here. There's a lot. Okay. Boop, 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 boop. So if you look at like other species, there's often a lot of stuff about their eyes that are super fascinating. So like, for example, an eagle's eye, they have like an incredibly dense center of their vision in what's called the fovea. And so that's the area of your eye that has the most retinal cells. Like it's the center of your retina. It's the spot that has all the detail. All right. Right in the center of your vision. That's where your fovea is. It has far and away the densest amount of cells in your eye. It's got cones and rods. Rods determine contrast. Cones determine color. And so that's why you get your best vision in the center. Ours is very dense. An eagle's is far, 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 far more dense. So what that ends up doing is allowing them to have that vision that's, you know, seemingly miles away, right? Like incredible vision. And all you have to think of is like their eye is a little bit closer to like a binoculars, but it's not a lens that's doing it. It's actually their eye. Their eye has a higher megapixel count just right in the center. And then off to the edge, it's far more, it's far less accurate, right? It's far less dense. I like these trees around here. Okay, cool. That's what I was thinking. I would like these in this area. Even though they're for the fire area, I think they fit in here as well. Right? The sort of red trees and things. Oh, I like that. Okay, so another thing that's super interesting about how your eyes work. So the different cells in your eyes, you know, I just mentioned it just a second ago, but it's the rods and the cones. The cones detect color and the rods detect contrast. So what that actually means is that in your peripheral of your vision, you actually have far more sensitive to light vision. So because there's no rod or no cones, the rods kind of get to have 100% of the info from there. So it's higher contrast in the edge of your vision. So you can actually see that there's pluses and minuses to having high density images. So the reason that this works, the reason that you have higher contrast in your periphery is not just because there's rods, but also because they compress more information. And because they compress more, they appear brighter. Why is that? So let's say, we're just going to say like units of light, okay? So we're going to say, we'll just say photons. So let's say in the center of your eye, you have a rod, and it requires 1 photon to fire. All right, every rod will just say requires 1 photon to fire a neurological charge, okay? So in the center of your eye, it's all pixel perfect information. It's 1-to-1, all right? You get 1 photon of light and you send an image down the neuron. So that gives you pixel perfect, right? That gives you all this information, but it's 1-to-1. Now, in the edge of your vision, you'll have more convergence between your neurons. So instead of a rod being like a 1-to-1, so it goes down the path, 1 photon equals 1 pixel, you can have, say, 5 rods or 10 rods all clustered around 1 neural response. So then what happens? Well, 1 photon is never going to be just 1 photon, right? There's a bunch of photons next to that other photon. So when those rods get stimulated, they cover a larger area, but they all go to the same point. So it's basically 5-to-1 or 10-to-1. So the experience becomes much brighter because that neuron's going to be firing faster. But because there's convergence, the image is going to be blurrier. So that's why in your peripheral vision, you actually can see things brighter. So you'll notice this on your own if you are, like if it's the middle of the night or something like that, and you see like a little light or maybe a star in the sky off in your periphery, and then you turn to look at it, it's nowhere near as bright. That's why, because you don't detect brightness as well in the center of your vision. So what this demonstrates that's important is that perfect vision is not perfect, right? If you want pixel perfect, you lose sensitivity. If you want sensitivity, you lose pixel perfect. That's just how our eyes work. So there is no perfect orientation of any eye in the animal kingdom. Instead, there are eyes that are successful for different species. Make sense? So your eyes are built to do what your species is built to do, not to try and be perfect, because perfect can't exist and isn't useful, right? It doesn't help you identify things. Your eyes are more sensitive in the peripheral because if something moves in your periphery or something changes, you're going to want to turn, right? You're going to want to look. And then your better vision in the middle can then attend to it and be like, okay, let's identify what's going on here. We're going to look a little bit closer. But at night, say, you're using your peripheral to navigate around, right? You'll notice this. If you're trying to walk around in the middle of the night and it's pretty dark, you have very low light, you'll notice that you're seeing the world a little blurrier, and it's because really what you're seeing through is just kind of your periphery and much less the center of your vision. Okay, I'm looking at time. We're right about at an hour. I had fun decorating this. Let's look again over what I did. It wasn't a ton. Actually, let's look and see if we have any other objects I want to put in here. Might have some flowers or something. I like we got those trees. You know what? Let's get rid of this stick one. We'll move it somewhere else. I don't like it right there. We want something a little more dynamic here. Well, let's put these guys in here for right now. No, don't like that. Don't like that. Pick that up. Okay. Well, maybe a rock thing. Maybe we'll do this guy. Yeah, I like that because it's on the rock thing. Okay. Dude, there's so many spots. I love that they've put so many tech spots like in clustered areas because you can really do neat designy things, you know? Like this is right next to this guy, right? We can give him something back here, you know? Let's maybe put... Let's see what else we got. Well, these are the only ones that we have right now. Okay. Do that. Okay, we're gonna put this big tree here. This is a good spot for it. So here's what it was. I didn't like this in the skyline because it's so rigid. It's so rigid. It just stood out. Whereas this like curvy line, curvy line, curvy line, I like those together. That over there though, that's good. I dig that because it's got the background to it, so it actually is okay in contrast. Love that tree. Love the other curved tree. Cool. You know what, let's kind of looking at it as we come through. Yeah. Now later on I might move things around and maybe like make them like regioned. Where like, okay, it's drier over here and maybe like more lush over there or something. But I dig it. I'm liking doing this. I'm liking just spending time. You know, we talk and we decorate. And eventually we're going to have like such a gorgeous ranch / conservatory. I'm just going to have to go get a bunch of resources. You know what I might do at this point? If y'all don't have a problem with it, I'd be curious to know, is just me come in here and gather some resources on my own. Maybe sometimes, you know, I can just like grind while I'm listening to podcasts, and that could be nice. I might do that. Oh, the hen situation is getting out of control. Out of control! Okay. Come here. Whee! Okay. Oh, man. Okay, I should just absorb them all, right? Because there's so many chicks. Oh, I could launch chicks into here. And then they'll grow. Oh, I'm curious about this now. What if you threw like 1,000 chickadoos into one of these and waited for them to grow? I'm not saying that's something I'm going to do because that is incredibly difficult just to even think about. But I wouldn't be shocked if the next time we come in here, these guys bust loose, or at least are much closer. Oh gosh, this is the silliest thing I may have ever done. Okay, so yeah, sound off below and let me know if y'all have a problem with me, like maybe spending a little bit of time and just grinding resources. Oh hey, just because, like I said, you know, it's slowing us down. Then again, you know, this is daily, slow and steady, y'all. So we'll continue to come back here and do some business out here. But you know what, y'all, that's been our hour and some change, because actually I just realized because I came back, so we're actually probably at like an hour and 10. Look at it, so much. But with that, thank y'all so much for watching. I appreciate it. Y'all, it's really great. I love having y'all who come here every day and check my stuff out. It really means a ton to me. If you can, please leave the like on the video. Leave one of them likes. Comment down below. That would be awesome. If you can't think of a comment, then maybe say, "The eyes tell lies." How's that? The eyes tell lies. Also, subscribe if you're not already, so you can check out more of my videos, and go look at one of my other videos. Maybe go check out something else I got on the channel. It helps a ton with the algorithm if you watch one of my videos and then watch another one, because it tells YouTube, hey, you like to see my videos, and other people like you probably will too. So yeah, that would be awesome. Any of those things, all of those things, if y'all can help out, share the video with your friends, or share some of my stuff with your friends, I'd love it. I'd love it. But none of that's as important, y'all, as what's most important, which is that I hope you have a wonderful rest of your day. I have been Price, and I will see y'all tomorrow. Bye-bye.